We are going to start now chapter 9 of class 11th mathematics, sequence and series, and this is lecture 1. So in this lecture we will talk about the arithmetic progressions. So these are some basic facts, and these facts we have also discussed in our previous lectures of class 10th, where we have studied this chapter of arithmetic progression. So the first definition we have over here, it is the definition of a sequence. So a sequence is succession of numbers that are arranged in a definite order according to a given set rules. That is called a sequence. And the number occurring at the nth place of the sequence is called the nth term or the general term, and it is denoted by an. So if we talk about an example, we are saying, suppose we are saying 2, 7, 14, 18, so on. So this is the position of these numbers. This position of this number, it is first. This number is at first position. This is at second position. This is at third position. This is at fourth position. So we are saying that we have arranged all these numbers and their positions, they are fixed. Then this forms a sequence. And the general term we write, it is an. This is the method of writing the general term. Next is a sequence is said to be finite or infinite if the number of terms it has, it is finite or infinite. Suppose I am writing it is 2, 7, 14, 18. So there are only 4 terms in this sequence, and this sequence we say it is a finite sequence. Whereas when we are writing the sequence in this way, we have written over here at so on, this sequence it continues in this way, then this kind of sequence it is an infinite sequence. Now by adding the terms of a sequence we get a series. So a series is said to be finite or infinite. We are talking about the partial sums. We will see the definition according as the number of terms in it is finite or infinite respectively. So we are saying, suppose we have a sequence A1, A2, A3, A4 and so on. Partial sum means I am talking about the S1. S1 means first term A1, then sum of 2 terms, it is A1 plus A2, then S3 is A1 plus A2 plus A3, S4 is A1 plus A2 plus A3 plus A4. So these are the partial sums, and when we are adding the terms of the sequence, we continue in this way. When we are adding the terms of the sequence, we are obtaining a series. So there is a definition for the sum of the series or the limit of the series. That is not the part of your syllabus right now. So you can just look at this, that by adding the terms of a sequence we get a series. So if we are adding all these terms, we obtain the series over here. Now the first question we have is, write the first 5 terms of the sequence given by an is equal to 2n plus 1. We have to write first 5 terms. So we are saying the value of n we have over here, it is starting from 1, then 2, then 3, 4 and 5. These are the 5 values of n we have. So we will have a1 is equal to 2 into 1 plus 1. In place of n we have written it as 1. So the answer we obtain it is 3. Next we have a2 is equal to 2 into 2 plus 1, that is equal to 5. Next we are saying a3 is equal to 2 into 3 plus 1 is equal to 7. Next we have a4 is equal to 2 into 4 plus 1 is equal to 9, and a5 is equal to 2 into 5 plus 1 is equal to 11. So the first 5 terms of this sequence, it is 3, 5, 7, 9, 11, so on. These are the first 5 terms, and it is being given obtain the corresponding series. Series means we are adding all these terms, we obtain this series. We are writing 3 plus 5 plus 7 plus 9 plus 11. So plus sign is there in between all these terms. So this forms a series. Next is write first 4 terms of the sequence given by this formula. It is an is equal to 1 by 6 into 2n minus 3. So we will have a1 is equal to 1 by 6 into 2 into 1 minus 3. a2 is equal to 1 by 6 into 2 into 2 minus 3. Then a3 is equal to 1 by 6 into 2 into 3 minus 3. and a4 is equal to 1 by 6 into 2 into 4 minus 3. So the answers we obtain on solving this, these are shown, these calculations, these are shown over here. We have, these are the values we are obtaining by solving all these terms. So the sequence we have, it is minus 1 by 6, 1 by 6, 1 by 2, 5 by 6 and so on. We have to write first 4 terms. So these are the first 4 terms, and the corresponding series to this, it will be sum of all these terms. It is important to note over here that if it is negative sign over here, we have written the negative sign over here. Next is the Fibonacci sequence. So it is a special kind of sequence. Its name is given over here. So it is of the form, we are saying a1 is equal to 1, a2 is equal to 1. The first 2 terms are fixed. Then the next term is given by the recurrence relation, an is equal to an minus 1 plus an minus 2, where n is greater than 2. So if we have to calculate the value of a3, we have, it is a2 plus a1. So the answer we obtain, it is 2. If we are writing a4, the answer we have, it is a3 plus a2, that is equal to 2 plus 1 is equal to 3. If we are writing a5, so it is sum of the previous 2 terms. So the answer we have, it is 5, and continuing in this way we obtain the Fibonacci sequence. Now what we have to do is, we have to find the value of an plus 1 over an. So we are writing a2 by a1, that will be 1, a3 by a2, a3 by a2, that will be 2, then a4 by a3, that will be 3 by 2, and a5 by a4, that is equal to 5 by 3. So we have to calculate these values for n is equal to 1, 2, 3, 4, 5. So these are the required answers in this case. Next is the definition of a progression. So it is sequence following certain patterns are called progressions. So the first kind of progression we have, it is the arithmetic progression. So it is a special kind of sequence where the terms that we have, we are talking about a sequence a1, a2, a3, a4, so on. We are saying, we are talking about a special kind of sequence where this term differ from this previous term by a constant value d. We are saying a2 minus a1 is equal to d. Similarly, this is equal to a3 minus a2, this is equal to a4 minus a3, and so on. This d may be positive, this d may be negative. So we are saying a sequence in which each term except the first one, there is no previous term to this first term, differ from the preceding terms by a constant, and that constant we denote by d, and it is called the common difference. This constant d, it is called the common difference, and the general term of this kind of sequence we write over here in the form Tn. So we have, first question we have is, show that the sequence defined by Tn is equal to 3n plus 5 is an AP. So if we write the two consecutive terms, one is Tn, next suppose we are writing Tn plus 1, Tn plus 1 is 3 into n plus 1 plus 5, that is equal to 3n plus 8. Now if we calculate the value of Tn plus 1 minus Tn, the answer we have, it is 3n plus 8 minus 3n plus 5. So this gives us the value as 3. This gives us the value as 3. So we are saying the given sequence is an AP with the common difference 3. Next is, show that log a square by b, log a cube by b square, log a4 by b cube, it forms an AP, and we have to find the common difference. So if we write the general term over here, it is Tn is equal to log of, when we are talking about say first term, it is b raised to the power 0 over here. So first term corresponding to this, we will have a by b, a raised to the power n and b raised to the power n minus 1. So Tn minus 1 term will be log of a raised to the power n minus 1 over b raised to the power n minus 2. Now if we subtract both these terms, we are talking about Tn minus 1. The answer we have is log of a raised to the power n by b raised to the power n minus 1 minus log of a raised to the power n minus 1 by b raised to the power n minus 2. It is minus sign between these two, so the answer we get it is log of a raised to the power n over b raised to the power n minus 1 into b raised to the power n minus 2 over a raised to the power n minus 1, and that is equal to log of a by b, and this is equal to d because it is a constant number independent of n. So we are saying that the given sequence is an AP with common difference log of a by b. Next is show that the sequence defined by Tn is equal to 3n square plus 2 is not an AP. So one method we have is that suppose we start writing the terms over here. The first term T1 we are writing it is 3 into 1 plus 2. The answer we have it is 5. We are writing T2 is equal to 3 into the value of n we are substituting 2, it is 4 plus 2. The answer we have it is 14. Next we are writing it is T3 is equal to 3 into 3 square plus 2. The answer we obtain in this case it is 29. So if we subtract these values, what is the difference between these two values? It is 14 minus 5, that is equal to 9. What is the difference between these two values? It is 29 minus 14. So the difference we have it is 15. So what we obtain from these two results is that the term the common difference we are talking over here, it is not constant. There is no common difference over here. The difference between the term and its preceding term, it is not fixed. So we are saying it is not an AP. So this is also a method to solve these kind of problems. Now the another way is we are writing the term Tn. It is 3n square plus 2. We are writing the term Tn minus 1. It is 3 into n minus 1 square plus 2. If we calculate Tn minus 1, we will obtain it is 3 into n square minus n minus 1 square. When we solve this value, the answer we will obtain it is 6n minus 3. And this term it is not a constant value. It is not independent of n. So we are saying it is not an AP. This progression it is not an AP. Next is general term of an AP. So we have to show that the nth term of an AP with first term A and common difference D is given by this formula. It is Tn is equal to A plus n minus 1 D. So suppose we are saying that the AP that we have, its first term is given to be A. So we are saying the first term we have it is A and common difference is D. So the next term will be A plus D. Next term will be, we will add D to it. So it is A plus 2D. Next term is we will add D to it. It is A plus 3D and so on. So what we have is that T1 is equal to A, that is equal to A plus 1 minus 1D. T2 we are writing it is A plus D, that is equal to A plus 2 minus 1D. T3 we are saying it is A plus 2D, that is A plus 3 minus 1D. So continuing in this way, when we generalize this result, we are saying it is A plus n minus 1D, and this is what we have to prove, that Tn is equal to A plus n minus 1D, and this term Tn, it is called the general term of the AP. And if an AP with first term A and common difference D, then we are saying that Tn is equal to this value. Next is some simple properties of an AP. So first is, if a constant is added to each term of an AP, then the resulting progression is an AP. We are saying we have A, next is A plus D, the next term we have it is A plus 2D, next term we have it is A plus 3D, and so on. What we are saying, that we have added some constant C to all these terms. We have added some constant C. Now what is the difference between these two? It is again D. The difference between these two, it is again D. The difference between these two, it is again D. Second is, so this is also an AP. Second is, if a constant is subtracted from each term of the AP, then the resulting progression is an AP. So in place of addition, if we subtract this value C from all these terms, again it is an AP. If each term of an AP is multiplied by same non-zero number, then the resulting progression is an AP. We are saying we have A plus D, A plus 2D, then A plus 3D, and so on. If we multiply each term with some constant C, which is a non-zero number, what we obtain is, it is AC, then AC plus CD, then AC plus 2CD, then AC plus 3CD, and so on. Now if we subtract these two values, the common difference will be CD. If we subtract these two values, common difference is CD. If we subtract these two, the common difference is CD. So what we are getting from this is that this new sequence, new progression we obtain, it is also an AP. Next is, if each term of an AP is divided by same non-zero number, then the resulting progression is an AP. So if we divide it with C, we are saying it is also an AP. Next is, show that the progression this is an AP. Find its general term and the 14th term. So the progression that is given to us, it is 17, 12, 7, 12, 17, 22 and 27. So if we subtract these two terms, the answer we have it is 5. If we subtract these two, answer we have it is 5. If we subtract these two, answer we have it is 5. If we subtract these two, answer we have it is 5. So the common difference we have, this is the value of D we have, this is the value of A we have. First thing we have to do is, we have to write the general term. So it is Tn is equal to A plus n minus 1D. The value of A we have it is 7. It is 7 plus n minus 1, and the value of D we have it is 5. So we are writing this is equal to 5n plus 2. This is the general term Tn. Next thing we have to do over here, it is we have to find the 14th term. So 14th term means we are talking about T14. So it is 5 into 14 plus 2, that is equal to 72. So this is the general term, 14th term that we have corresponding to this AP. Next is, show that the progression log A, log AB, log AB square, log AB cube is an AP. So if we write these terms over here, we are talking about log of AB minus log of A. The answer we obtain, it is log of B. Why? Because this log of AB, we can write it is log of A plus log of B. So answer we obtain, it is log of B. Next is log of AB square minus log of AB. We are talking about the difference of these two terms. We get it is equal to log of AB plus log of B minus log of AB. Again these two terms get cancelled, and the answer we are left with is log of B. Similarly, if we subtract the next two terms, the common difference we will have it is log of B. So we are saying this given progression, over here, it is an AP. The first term corresponding to this AP, it is log A. The common difference we have, D, is log of B. We have to find the general term and the 10th term. So Tn is equal to A plus n minus 1 D. So we can write the general term in this way, and the 10th term, that will be log A plus 9 times log B, that is equal to log of AB raised to the power 9. So this is the 10th term, and this is the general term that we have. Next is, show that the progression this is an AP. Write its first term and the common difference. So AP given to us, the sequence given to us, or it is 12, 16, 11, 6 and 1 and so on. Now if we subtract these two values, the answer we have it is minus 5. We are saying it is 16 minus 21 is minus 5. These two values if we subtract it is minus 5. These two values if we subtract it is minus 5. These two values if we subtract it is minus 5. So the value of A we have it is 21. The value of D we have it is minus 5. So this is the first term we have it is 21 and the common difference we have it is minus 5. Next is which term of this AP it is minus 54. So to calculate this value, we are saying suppose the nth term, its value is minus 54. So we are saying Tn is equal to minus 54 is equal to A plus n minus 1d. So it is 21 minus 5 into n minus 1. This value is equal to minus 54. So on solving this we will obtain that the value of 5n that is equal to 80. So this implies us that the value of n we have it is equal to 16. It means we are saying that the 16th term of this AP it is minus 54. Next is show that this progression is an AP. How many terms does it have? So it is a finite progression. It is minus 11, minus 7, minus 3, 1, 5, so on up to 161. This is the last term over here. So if we calculate the difference over here, it is minus 7 plus 11 that is equal to 4. Between these two it is minus 3 plus 7 is equal to 4. Then it is 1 plus 3 is equal to 4. Then it is 5 minus 1 is equal to 4. So we are saying the value of A we have it is minus 11. The value of D we have it is 4. And the value of Tn, we want to calculate the value of n, and Tn is given to be 161. We are saying suppose it is the nth term where we want to calculate the value of n. So this is equal to A is minus 11 plus n minus 1 into D is 4. So on solving this we will obtain that 4n is equal to 176. So this implies us n is equal to 44. So we are saying the 44th term, this 161, it is the 44th term of this AP. That is, this AP has total 44 terms. This AP has total 44 terms. Next is 319 a term of this AP? So the terms given over here it is being given that this is an AP. It is 11, 17, 23, 29, 35 and so on. So the value of A we have it is 11. The value of D we have it is 17 minus 11 that is equal to 6. You can use any two values to calculate the value of D. Now we want to find, suppose we are saying the nth term that is equal to 319 for some n. So we are writing this is equal to 11 plus n minus 1 into 6. Now if we solve this equation we will obtain 6n plus 5 is equal to 319. So this implies us that the value of 6n we have it is 314, and this implies us that the value we have it is 157 by 3. We are saying this n we are considering it is a natural number because it is a sequence. It is the term, first term, second term, third term we are talking about. So this n does not belong to n. This is not a natural number. So we are saying that there is no value of n for which Tn is equal to 319. It means 319 is not a term of the given AP. Next is which term of the AP this is the first negative term. So this AP is given, its terms are 30, then 29 whole 1 by 4, then 28 whole 1 by 2, 27 whole 3 by 4 and so on. It is being given that this is an AP. So the common difference D we can calculate it is 29 whole 1 by 4 this is minus 30. So the answer we have, it is equal to minus 3 by 4. The value of a we have, it is 30. The value of Tn we are saying it is a plus n minus 1 into d, and we want to find the first negative term. It means we are interested in the least value of n for which this value is less than 0. So what we obtain from solving this, it is 123 minus 3n is less than 0. This implies us that the value of 3n is greater than 123. This implies us n is greater than 41. It means we are talking about, we have, this is a1, a2, so on up to a 40th term, a 41st term, a 42nd term, and so on. And we are saying for n greater than 41, that is for all these terms, we have all these terms, these are negative terms. So the first negative term we are saying it is basically a42. So we want to calculate the first negative term. So it is t42, that is equal to 30 plus 41 into 3 by 4. Answer we have, it is minus 3 by 4. So we are saying that t42 is equal to minus 3 by 4. It is the first negative term of this given AP. Next is find the 10th common term between the series 3 plus 7 plus 11 plus 15 plus so on. And second is 1 plus 6 plus 11 plus 16 plus so on. Now the first common term we have, it is 11. This is the first common term. Like this we have to calculate the 10th common term. So if we calculate the common difference over here, the common difference for this first series, it is 7 minus 3, that is equal to 4. And common difference for this second series, it is 6 minus 1 is equal to 5. We are saying this term, it is a common term over here. Now the next common term we will have, that will be after the 20 units. How we are getting 20? The two values we have, it is 4 and 5. So the LCM of these two values, we are saying LCM of these two values 4 and 5, it is 20. How we are getting? It is 3, 7, 11, 15. Next 4 will be added to it, it will be 19. Next 4 will be added to it, it will be 23. Likewise, we are saying it is 1, 6, 11, 16. Then it is 21. We are saying 5 is added to this term, 4 is added to this term. Then 4 is added to this, 5 is added to this. We get it is 26. So the common value we will obtain when 20 is added to this term and 20 is being added to this term. We are talking about this 11. We are saying when 11 plus 20 we will do, we will get it is 31. 11 plus 20 we will get it is 31. So that will be the next common term. So we are basically interested in a new sequence whose first term is 11, whose common difference is 20, and we want to calculate the 10th term. So T10 we want to calculate. So it is A plus 9 into D. So the answer we obtain, it is 11 plus 180, that is equal to 191. So we are saying that 191 is the 10th common term of the two given series. Now the next question we have is, if A1, A2, An, this is an AP with common difference D, the difference over here it is D, then we have to prove this result, that this value is equal to cot A1 minus cot A2. So this term cosecant A1, cosecant A2, we can write it in the form, we are saying it is sine of a2 minus a1, this is the value of d we have, divided by sine of a1 into sine of a2. Second term, this is the first term, second term we have it is sine of, we write it is in place of d, now we are writing a2 minus a3 minus a2, and in division we have it is sine of a2 sine of a3, and continuing in this way we will have sine of an minus 1 divided by sine of an minus 1 sine of an. Now if we use the formula sine of a minus b in the numerator, we will have, I am talking about this first term, I am just talking about this first term, this will become sine of a2 cos of a1 minus cos of a2 sine of a1 divided by sine of a1 into sine of a2. If we separate both this denominator part with both the terms of the numerator, we will obtain it is cos of a1 over sine of a1 minus cos of a2 over sine of a2, and this value comes out to be cot of a1 minus cot of a2. So corresponding to this first term, we have cot of a1 minus cot of a2. Corresponding to this second term, we will have cot of a3 minus cot of a2 minus cot of a3, and corresponding to this nth term, we will have plus so on up to cot of an minus 1 minus cot of an. Now look at these terms over here, this cot of a2 gets cancelled over here, this a3 will get cancelled with the next term, and this an will be cancelled. So what we will be left finally will be cot of a1 minus cot of an, we will be left with this term. So we are saying this is the required answer, that this value is equal to cot of a1 minus cot of an. Next is, if a1, a2, a3, an are in AP, we have to show that 1 over square root of a1 plus square root of a2, 1 over square root of a2 plus a3, so on up to this term, the sum of all these values is equal to n minus 1 over square root of a1 plus square root of an. So it is being given that it is in AP. So if we consider the left hand side of this equation, we are talking about these terms, and we rationalize these terms. Look at this first term over here, it is 1 over square root of a1 plus square root of a2. We are writing it is square root of a2 minus square root of a1 divided by square root of a2 minus square root of a1. So it is equal to square root of a2 minus square root of a1 by a2 minus a1, and a2 minus a1 value we have it is d. So if we use this result for all these terms, we will have square root of a2 minus square root of a1 by d. Next term will be square root of a3 minus square root of a2 by d, so on up to plus square root of an minus square root of an minus 1 by d. So if we write 1 by d common, this a2 gets cancelled with a2, an minus 1 will get cancelled over here, we are left with this square root of an minus square root of a1. Now we require the answer in this form, so we are writing it is square root of a1 plus square root of an into square root of a1 plus square root of an. This is equal to 1 by d into an minus a1 divided by square root of a1 plus square root of an. Now in place of this an we can write, this is the general term an, we can write a plus a1 plus n minus 1 into d. This a1 gets cancelled, this d and d gets cancelled, and the answer we are left with is n minus 1 over square root of a1 plus square root of an, and this is what we have to prove. Next is if a1, a2 so on up to an is an AP of non-zero terms, then we have to prove this result. So again a2 minus a1 will be d, a3 minus a2 will be d, the common difference d will be there. Now we are talking about this term, it is 1 over a1 a2 plus 1 over a2 a3 so on up to plus 1 over an minus 1 into an. If we multiply and divide the numerator and denominator with d, for this first term, look at this first term, we are writing it is a2 minus a1 by a1 minus a2, a1 into a2. So that is equal to 1 by a1 minus 1 by a2. So the answer we are getting over here, it is 1 by d is common. It is 1 by a1 minus 1 by a2. The next term will be 1 by a2 minus 1 by a3. And likewise we will have 1 by an minus 1 by an. In these terms, this a2 gets cancelled, a3 gets cancelled, an minus 1 gets cancelled, and what we are left with is 1 by d into 1 by a1 minus 1 by an, that is equal to 1 by d into an minus a1 by a1 an. Again if we substitute this value of an minus a1, we are saying an is equal to a1 plus n minus 1d. So an minus a1 is n minus 1d. We are getting the answer as 1 by d into n minus 1d divided by a1 into n. This d and d gets cancelled, and the answer we are left with is n minus 1 by a1 into an, and this is the required answer. Next is in an AP the pth term is q and p plus qth term is 0. We have to prove that the qth term is p. So it is being given that in the AP the pth term we have, it is equal to q, that is equal to a plus p minus 1d. The p plus qth term, it is given to be 0. So we are writing it is equal to a plus p plus q minus 1d. So we are having these two equations now. Now if we subtract both these equations, we get q is equal to, this a gets cancelled, we are having pd minus d and minus pd minus dq, and the next term we will have it is minus, we are subtracting this term, so it is plus d. So this d and d gets cancelled, this pd and pd gets cancelled. So what we obtain is that qd plus q is equal to 0. So this implies us that q into d plus 1 is equal to 0. Now clearly q cannot be 0, so this implies us that the value of d we have, it is equal to minus 1. Now if we substitute the value of this d in the first equation, we are saying we substitute this value of d in the first equation, we obtain q is equal to a plus p minus 1 into minus 1. So we obtain the value of a is equal to q plus p minus 1. We have the value of a is equal to this, d is equal to minus 1. Now we want to calculate the qth term. So tq will be equal to a plus q minus 1d. We substitute these values over here, a is q plus p minus 1 plus q minus 1 into minus 1. So it is equal to q plus p minus 1 minus q plus 1. Q and q gets cancelled, 1 and 1 get cancelled, and we are left with is p. So we are saying that the qth term we have is p. So we are saying the qth term we will have it is